Hi everyone, welcome to the next video of solving most important DSA interview questions. So in this video, we are again going to solve another graph problem. The name of the problem is course schedule. So the problem statement is there are a total of num courses you have to take right, which are labeled from 0 to num courses minus 1, and you are given an array prerequisites where prerequisites of I is equal to a of I comma b of I indicates that you must take course bi first if you want to take course ai. For example, they have given that the pair 0 comma 1 indicates that to take course 0 you have to first take course 1. Return true if you can finish all the courses, otherwise return false. So here you can see that there are two courses that they have provided that we have to take, right? And prerequisites are basically 1 comma 0. So let's understand this question properly. So let's say these are the prerequisites that you are given with, right? So basically 0, 1, 2 and 3 are basically the courses, right? And they have also given how many courses that you have to take. So basically here is 2, so you may consider any courses here. So first of all, let's discuss about its prerequisites. What does it mean? So it is given that to complete course 0 you have to first take course 1. So let's write it here is that for completing course 0 you have to take course 1, complete course 1 first, right? And also the second one is that for completing course 1 you have to complete course 2 first. So here we will write 2 first, right? To complete course 1 you have to complete course 2, right? Again, the third prerequisite that to complete course 2 you have to first complete course 3. So what does it mean that for completing course 2 you have to first complete course 3? So in this way you have to complete your course, right? So you can notice here is that if we go according to these prerequisites, we are actually able to complete all the courses, right? So let's say they have given that you have to complete 2 courses, right? So you can see you are actually completing 4 courses, or either they had given like you have to complete 3 courses, so you are actually completing 4 courses, right? So in this manner, so in this question you are actually able to complete all the courses, right? Now let's come to the next example. So let's see here, you are given that for completing course 2 you have to first complete course 1. So what does it mean? For completing 2 you have to first complete 1, right? Also they have given that for completing course 3 you have to complete course 4 first, right? So let's write it here. For completing course 3 you have to first complete course 4, right? Now in the third prerequisite they have given that for completing course 4 you have to complete course 2. So you can see here we have already completed course 2, and then after we are completing course 4, so it is already done, right? So this is done, this is done, and this is done. Now the last case is for completing course 1 you have to complete course 4. So you can see here is that for completing course 1 you have to first complete course 4. But what in our previous cases we have seen that first of all we have to complete course 1, then course 4. So there is a contradiction here, right? So you can see that you can also notice here is that we are actually moving from 1 to 2, then 2 to 4, then 4 to 3, right? Then in the last case what we are seeing that we have to move from 4 to 1. It means that for completing one we have to first complete 4, right? So there is you can see that there is a cycle present if you are considering it as a graph. So let's say this was node 1, this was node 2, this was node 4, and this was node 3, right? And you can see that we were moving from node 1 to node 2, then node 2 to node 4, then node 4 to node 3. Now for completing 4 we require to complete 1 first. So if you are considering age between these nodes, so there will be an age from 4 to 1. So you can see that if there is a contradiction when there is a cycle present in this graph, when you will consider it as a graph, right? So you cannot complete this all the courses if according to these prerequisites, right? So if they had provided that you have to complete all the courses, so you would not be able to complete all the courses, right? So we have to solve this question and return true if we are able to complete the number of courses that they have provided. Let's say they have provided here 2, so we have to complete 2. Let's say in this question if they had provided that you have to complete only 2 courses. So here you are actually able to complete 4 courses. So in that case, okay, so we don't have to. Let me check. No, no, I'm sorry. The num courses are basically representing the total number of courses that are present. It doesn't matter. It doesn't have any relation that how many courses that you have to complete, right? So basically, you have to check for these prerequisite array that whether there is a cycle present in that, right? So there are many videos on YouTube that they are providing solution using topological sort. But what I am going to use here is that technique of finding cycle in the graph, right? So we can also solve this problem using cycle detection in a graph. So if there is a cycle present in a graph, so what does it mean? Basically, there is a contradiction that we cannot. There is a cyclic dependency on the nodes, right? So completing one, you have to complete other. For completing other, you have to complete the other, right? So this is cyclic dependency. So we will what we will do? We will basically do a cycle detection in our graph. If cycle is present, so we will return false that we cannot complete these courses. Otherwise, we will return true, right? So how we will do our cycle detection in that graph? So let's see how we can do that. So let's say you are given with this graph, right? So you can see here there is a cycle present. Uh, okay, here is there is a cycle present in this part of the graph, right? In this part you can see that we are going from 4 to 5, then 5 to 6, then again to 4, right? So this is a cycle present. This is not a cycle, right? Because we are going to 3, then 8, but we are not returning back to 3 from 7 to 3, right? So this is not cycle, but this is a cycle here, right? So how we will find that there is a cycle in a graph? So if you are studying graph questions, so you must be knowing about how to create adjacency list, right? So first of all, what adjacency list means that you have to create all the adjacent nodes corresponding to all the nodes, right? So let's create adjacency list here. So first of all, we will consider all the nodes and create the adjacent nodes and store the adjacent nodes corresponding to them. For example, let's say 1 is here. For node 1, what are the adjacency nodes? For node 1, only 2 is the adjacent node, right? And for node 2, what are the adjacent nodes here? So for node 2, you can see that there are 2 adjacent nodes, that is 3 and 4. So why one we are not considering 1 as adjacency node? Because this is a cyclic directed graph, right? And we consider the neighbor from that node and where we can go from that node, right? So we can go from node 2 to 3 and 4. That's why these 2 nodes are adjacent of node 2, but we cannot go in the backward direction from 2 to 1. Why? Because there is a directed graph, a directed edge from 1 to 2, right? So there are 2 edges, uh, 2 adjacent nodes for node 2, right? For node 3, what are the adjacent nodes? For node 3, you can see that 7 is one node and 8 is another, right? Now let's consider node 4. For node 4, what are the adjacent nodes? Only 5 is there. For node 5, what are adjacent nodes? For node 5, there is only one, that is 6, right? For node 6, there is an adjacent node called 4, right? Now for node 7, which is the adjacent node? For node 7, there is no adjacent node, right? Because from 7, you cannot go to anywhere, right? For node 8, what are adjacent nodes? For node 8, you can see that 7 is the only adjacent node, right? So this list is basically called as what? Adjacency list, right? So let's name it as adjacency list, right? Now since we have created adjacency list, so what we will do of it, right? So what we will do, we will use 2 data structures. For one is called we will check that whether we have already visited or not to a particular node, right? We will use a visited, let's say, map of int comma int visited, right? Which will keep track of the nodes which are already visited. And another thing that we are going to use is another map for checking whether we have already called DFS for that function or that node or not. So what does it mean? That let's observe something that I am going to tell you here, right? So let's say you call a function call from here, DFS call, right? We are going to use DFS call here. Let's say you call DFS from node 1. So first of all, what you will do, you will create that what visited of So let's say you create an array here. So this is visited array, right? How many? 0 to 8, right? Sorry, 1 to 8. So 1. So these are two data structure that we are going to use here. First of all, I have used visited, and another is DFS visited, right? So why I am using this? Let's understand this by observing something here, right? Let's say you call a DFS call here for one, right? Uh, you call DFS call for one. So what? So here you can see that in our visited array, first of all the elements are marked with false, or you can say 0, right? Why? Because initially we have not visited any node, right? Also, DFS visited basically means representing that you have called DFS for that node or not. So initially all are zeros, right? Now let's say you start your calling a function from node 1, right? So what you will do, first of all, you will call it as visited, right? So it will be visited, and also DFS visited, you will mark it as true, right? Now okay, so it's true, right? Now you will check what are the neighbors of node 1. So for checking the neighbors of node 1, you will go to your adjacency list and check the neighbors of node 1. So what is the neighbor of node 1? So 2 is basically the neighbor of node 1. So you will come to 2 here, right? So when you come to 2, you will mark your visited as true for 2, and when you again you will call uh, DFS for this node 2. So DFS call for 2 is done, right? So in this DFS call, you will again check the neighbors of this node 2. So what are the neighbors of node 2? So here you can see that 3 and 4 are the neighbors of node 2, right? So you, let's say you first go to 3, right? So you came to 3, you marked visited for 3 true, and again you will call DFS call for 3, right? So you will call DFS for 3 and check in that DFS call for 3 what are the neighbors of 3. So 7 and 8 are the neighbors of 3. So what you will do, let's say you first went to 7 here. So let's say you come to 7 here, right? So you will mark visited for 7 as 2, and again you will call DFS for 7. So when you are calling DFS for 7 and checking that is there any neighbor for 7? So there is no neighbor for 7, right? So what you will do, you will return from there back to 3, right? And mark that DFS call for 7 as false, right? Because we are returning from there. Okay. So okay, let me control Z, right? So you marked DFS call 7 as false, right? And you come back to 3 again, right? So when you came back to 3, again the another neighbor is 8, right? We already have gone to 7, right? So visited is 7 is 2, that's why we are not going again to 7. So you will go again to 8, right? and marked 8 as visited, right? And you will call DFS for uh, DFS call for node 8, right? So again, in DFS call, what is the neighbor of node 8? So 7 is the neighbor of node 8. So right. So you will mark DFS call for 8 is true. Now you can see that 7 is already visited, but DFS call for 7 is not true. So why? We had returned from there as there were no neighbor for 7. So since it is already visited, but DFS call is not true, so we will again go to 7 here, right? So we went to 7 and mark. So since 7 was already marked as true visited, and we will again call DFS for 7. So we will make it a true, but in DFS call we will again check whether 7 has any neighbor or not. So since there is no neighbor, so we will unmark DFS call for 7 and come back to 8. Again, when we came back to 8, so we saw here that uh, there is no other neighbor other than 7. So we will again go back to 3 here. So similar for 3, we already have checked all the neighbor, that is 7 and 8. We go back to 2. So for 2, we have already checked for node 3. Then we came to node 4, right? You can see here for 2, we have already checked for 3. Now we came to 4, right? So for 4, what we will do, you will mark visitors as true, and again you will call DFS for node 4. So when you will call DFS for node 4, you will mark it as true, DFS visited, right? And go it to neighbor. So what is its neighbor? Its neighbor is basically 7. So you come to 7 here, right? So basically its neighbor is 5. So you came to 5 from 4, right? So you will mark 5 as true, and you will call DFS for 5. So you will also mark DFS visited for node 5 as true. Now what is the neighbor of node 5? So 6 is the neighbor. So again you will go to 6. You came here 6. You mark visited 6 as true, and DFS call for 6 also true. So what is the DFS neighbor for that 6? So it's 4. So again you came to 4. So what you can notice here is that for node 4, the visited is already true, and DFS visited is also true. So what it means, you can see here we have actually got a cycle here, right? You can see. So from this example, we can make a conclusion that if, okay, so let me make it bigger, right? If your visited for of node is true and DFS visited of node is also true. So what does it mean? So what does it mean? It means that there is a cycle present in the graph, right? What you will do? You will return false, that we cannot complete all the courses here, right? So these nodes are basically representing all the courses, and this directed edges are basically the prerequisites or the dependency that are given in the questions, right? So in this way, we will solve this question. So let's come to the code part. So first of all, what we have to do, what I had said you that we have to first construct the adjacency list, right? You can see here we have constructed that, right? So we will construct that. For that, what you will need, we will need unordered map of type int, comma, you can say vector, right? Because for every node, we are storing multiple elements, right? So we will store it in a vector. So you can mark it as adjacency list, right? ADJ, right? Let's name it as ADJ. Now what you will do, you will traverse all the nodes. So basically the nodes are numbered from 0 to n minus 1. You can see here, let's say number of courses is basically represented by n. So these are labeled from 0 to n minus 1, right? So we will use for loop for that. I is less than n, then I plus plus. So what we will do, first of all, we will use that prerequisite array here that we are given with 2D vector. Let's call it as u to the first part of, it's basically the pair, right? It's basically the pair. Here you can see that in the example, it's basically a vector with size 2. So you can also consider it as a pair. So for accessing the this, so this will be your u, and this will be your 1 will be your u and 0 will be your v. Why? Because you have an a's from u to v, right? So vector of I'm sorry, it's prerequisites of I comma 0. It will be your u, and what is your will be v. So it's node, actually u and v are nodes, so it's basically prerequisites of I comma 1, right? And again, what you have to do, you have to basically push this uh, v corresponding to u, right? Adg of u dot push back what v. You will do it, right? So you can understand it here from here that u is 1 and 2 is v. So corresponding to 1, you have stored a vector which containing 2, right? So the same I am doing here, right? So this will be your adjacency what you can say list, right? Now you have created, since you have created adjacency list, what you will do, you will start calling DFS call for each node for checking the cycle, right? So for that, what I had said you that we will need two data structure. The first one is uh, visited and DFS visited, right? So let's create it out. So int comma int visited, right? Another is of same type. So basically control plus C, and the type of it will be int comma bool. Basically we have to check whether it is DFS call have done or not. Okay, DFS visited. Here is some change that we can also make it as bool, so it will be easy for us to check whether it is true or false, right? We mark it as true or false, right? So basically what I'm saying that if there is false in this visited vector, we will mark it as true, or if it is already true, so we will return from that, right? So I make it as a another map of type int comma bool, right? Now we will traverse all the nodes, right? For that we will use again a for loop I is less than n I plus plus. So what we were doing, let's say for node 0, first of all we will have to check if it is not visited of this node I, right, is not true. So what we will do, we will call DFS for checking the cycle, and we'll pass this what I, that is node, right, and adjacency list that we will need to check for its neighbor, right, and also the visited vector for checking its neighbor whether they are visited or not, and another is DFS visited, right? And we will store its value in any variable. Let's say bool is cycle. Let's say it returned true, right? So if is cycle is true, so what you will return, you will basically return false here. And if you are not returning false, so basically it returning true, so you will come out of the loop for traversing the all the nodes, and you will return true here. That actually we can complete all the courses. So we have to make this DFS function here. So the type of this function is bool, right? So let's say we created this function. Okay, so what are the parameters of it? So it's basically int I. What was I is basically node, and then adjacency matrix, so you have to take it as like it, right? So let's copy this out and mark it as ampersand, so that it is passed by reference, not copy is not created, right? And again you have to pass these two vectors, that is first visited one and DFS visited. So let's copy this also. Okay, so and make them all as ampersand, right? So no copy is created, the reference is passed, and we have to create this function, right? So what we will do in this function here, so first of all what you will do, you will check whether this no, we have already checked for that, right, it is visited or not. Now here what we have to do, we have to mark it as visited, right? So we have come to that node, right? So visited of this node is equal to true. So you are on this node, and you will be calling this DFS call for its neighbor. So before calling that, what you will do, you will mark DFS visited also for this node as true, right? Now you will go to, so what I did here is that I came to node 2 and mark its visited and DFS visited as true. Now I will have to make call for its neighbor, right? 3 and 4. So what we will do, that's why we had used adjacency list here. We will use it here, right? For we will accessing the neighbors of that node. So for that we will use a for loop. Let's say for auto and percent neighbor. Let's call them neighbor of adj of node, right? So we are basically uh, checking the that nodes all the neighbors, and we will check here that if it is not visited of, if that neighbor is not visited, so what we will do, you will basically again call dfs for that, right? So what we had seen here is that let's say 2 was not visited, so what 3 was not visited, so what we were doing, we are again calling dfs call for this node, right? So we will go to 7, mark it as true, and again we will call dfs call for 7. So this is recursive call basically. So here neighbor will become the node here. So neighbor will be the node, and we will pass adjacency list as its parameter, then visited matrix, and then other is what, dfs visited. So we passed it out, and let's say you store its value in another variable called cycle detected, right? You stored its value which will return, and if it returns true, if cycle detected, what you will do, you will basically return that cycle is present in this graph. Otherwise the other case is, if cycle is present, we will return from here. If that is not the case, so what does it mean? It means if it is not, neighbor is not visited, what does it mean? We will again check for another condition that if it is already visited, so basically if you didn't came to this if loop, if condition, that if it is not visited, if you don't come to this if statement, so what does it mean? The node is already visited, but we have to check that if its dfs call is has already been made. If dfs visited of node is already true, so in that case you will also return true, right? Right. So what was happening here is that when we gone to 4 from 6, we saw that 4 is already visited, and dfs visited of 4 is also true. It means that there is cycle present here. So what we are doing here is that if you are not going to this if statement, it means that that node is already visited, and also we are checking that if dfs call for that node is already made, it means there is a cycle. So we are returning true here. Other than, you will come out of this loop. So what does it mean that if there is no cycle, so we are going back to the previous node. So dfs I'm sorry, dfs, sorry, you will mark dfs visited of that node as false. You can understand from here is that when we were at 7, so there were no neighbor nodes from for this, right? So we returned back from this node. So what we are doing at that place, we were basically marking dfs visited for that 7 as false, right? So that when we again go to 7 from this 8 node, so we will call the dfs call for that node 7 also, right? So we marked it as false, and we returned false here, right? So at the end, this is cycle will store the value either true or false. If cycle is present, it means you cannot complete all the courses, so you will return for false, right? If you came out of this for loop, it means that you have checked for all the nodes, and we are not getting any true value from here. So what does it mean? We are not getting any cycle, so you will return true if there is no cycle in this graph, right? So this is the code for this problem. So let's try to run for public test cases. Okay, so use of undeclared identifier. Okay, so I am using DFS visitor. Let's make it as DFS visited, right? DFS visited of node undeclared identifier DFS visited where line number 5. Okay, so Make it bigger. Here I have used DFS. Let's make it as DFS visited, right? So it's telling that n is not defined. So what is n in our case? You can see here we are using n here. So what is n? N is basically num course, right? So num courses, again run this. Okay, the spelling is wrong. There are a lot of error here. Again there is n. Now what is error? 28. We are trying to access some values which are not allowed. So here some overflow is happening. Okay, so there is a silly mistake here, is that while creating this adjacency list, we are traversing our prerequisites array less than num courses. So basically, this is not the size of prerequisite, right? So basically, the size can be differ. So we will have to create a variable for storing its size. Dot size, right? Now we will be using n here, right? Now let's try to run this out. Okay, our first test case are failing, right? Why? So again, here we have done a mistake that we have to call it for neighbor, right? And we are calling for the node itself. Now again run this. Okay, you can see that our public test cases are passing. So now let's try to submit this out. You can see our code has been accepted, and this was the code for this problem statement. Uh, so so I have solved this question using cycle detection, and you can solve it using topological sort also. So there was a lot of videos on topological sort. That's why I decided to make a video, so that make this video using cycle detection, so that you can have another perspective of solving this problem, right? So talking about the time complexity of this problem, so basically the time complexity will be the size of these so basically will be number of nodes itself, right? So we are traversing the number of nodes, each nodes, right? So it's basically big of n, or you can say num courses. And talking about its space complexity, so it's basically big of n, because we are using two data structures, visited and DFS visited, for checking whether the node is already visited or a DFS call has been done for that node, right? Okay, so this was the solution of this problem. I hope you have understood this. So let's meet in the next video. Till then, have a nice day.